verify that A into adjoint A equal to adjoint A into A equal to determinant A into identity matrix, of course, of the same order. So presently we are given a matrix of second order, and you know what is adjoint A. How do you define adjoint A? It is transpose of a matrix in which each element is replaced by corresponding cofactor, that is C11, C12, C21, C22. And you know the signs to be imposed on the corresponding minus. So now let me write directly what is C11. Delete the row and column through 2. You get minus 6, and it being plus out here. So with the same sign it will remain minus 6. Now for C12, delete the row and column through 3. You get minus 4. But then with the change sign, so minus into minus, you get plus. And of course transposability. Then for C21, delete the row and column through minus 4, you get 3 with the change sign, so C21 will be negative 3. And then for C22, delete the row and column through negative 6, the opposite element is 2 with the same sign, so that will remain 2. So you get minus 6, 4, minus 3, 2. Don't forget to take the transpose. So by taking transpose, you get the elements of the first row, negative 6, 4, right in the first column, and that of the second row, minus 3, 2, right in the second column, minus 3, 2. So finally, the value of adjoint A comes negative 6, negative 3, 4, 2. And now we have to verify that A into adjoint A equal to adjoint A into A equal to determinant A into I, that comes later. So let us first find out A into adjoint A. What is matrix A? Matrix A is 2, 3, minus 4, minus 6 multiplied by adjoint A. Adjoint A we worked out as minus 6, minus 3, 4, 2. Now take the product of 2. You know how to take the product of two matrices? Both of them being of the order 2 by 2. The product will also be of the order 2 by 2. And how do you take the product? Row to column. So it will be 2 into minus 6, that is minus 12, and 3 into 4 plus 12. Continue to multiply with the first row to the elements of the second column. You get minus 6 and plus 6. And then repeat the same process with the second row. Second row, elements of second row multiplied with the first column, you get 24 and minus 24. Repeat the process with the second column, you get 12 minus 12. So by the way, if you look at it carefully, all the elements are 0 each. So you get 0, 0, 0, 0. That is, A into adjoint A is 0, 0. Call it 1. Now let us work out adjoint A into A. Adjoint A into A. What is the value of adjoint A? Minus 6, minus 3, 4, 2. And what is the value of A? The given matrix is 2, 3, minus 4, minus 6. You know, both of them being square matrix of order 2, the product will also be a squared matrix of order 2 by 2. And how do you multiply? The first row with first column, multiply the corresponding elements, you get minus 12 and minus plus 12. Repeat the process with the second column, you get minus 18 plus 18. And now take with the second row, that is the second row with the first column, you get 8 minus 8, and repeat the process with the second column, you get 12 minus 12. So what do you find? That you get again a 0 matrix of second order 0, 0, 0, 0. So at least we have verified that adjoint A into adjoint A equal to adjoint A into A, and that is a 0 matrix 0, 0, 0, 0. Call it say second. What more we have to prove? That the same is equal to determinant A into I. What is the value of determinant A? The given matrix is 2, 3, minus 4, minus 6. So the value of determinant will be minus 12 minus 12. So plus 12, it is 0. So now what is the value of, we have to prove it equal to determinant A into I. So what is the value of determinant A into I? Determinant A is 0. The identity matrix of second order is 1, 0, 0, 1, 0, 0, 1. Multiplying by 0, each element to be multiplied by 0, you get 0, 0, 0, 0. So now, what do you find? Comparing second and third, we find that A into adjoint A into adjoint A is same as adjoint A into A and is equal to determinant A into I, because each one of them is a zero matrix of second order, and that's what we have to prove. Verify that A into adjoint A equal to adjoint A into A equal to determinant A into I. Let me first of all work out the value of determinant A. What is determinant A? You know, we may expand it with any one row or column, but do you find here that the elements in the second column, you have got 2 zeros. So let us expand to get the value of determinant A along C elements of C2. You know the sign convention? It is plus, minus, plus, minus, plus, minus, plus, minus, plus. So along column 2, you have minus, plus, minus. So how do you take it? The element is already minus 1. So minus times minus 1. And now, you know, delete the row and column through minus 1. This minus 1. What do you get? You get 3 minus, delete the row and column through minus 1. You get 3 into 3. Okay, let me write here. You get 3 minus 2, 1, 3. So you get minus minus plus 1 time 1 outside, and you get 9 minus minus plus 2, so you get 11. So what is the value of determinant A finally? The value of determinant A is 11. And what is the extreme right hand side? Extreme right hand side which we have to prove, the right hand side which we have to prove is determinant A into identity matrix. Let me prove this also. 11 times what is determinant A is 11. And what is identity matrix? 1, 0, 0, 0, 1, 0, 0, 0, 1. So when you multiply it by 11, you get 11, 0, 0, 0, 11, 0, 0, 0, 11. So we have worked out at least, you know, the value of determinant A into identity matrix. If now I could prove that A into adjoint A and adjoint A into A is also the same. So we have done one job. Let me find adjoint A. So for that, just write the given matrix A again. What is the value of A? 1, minus 1, 2, 3, 0, minus 2, and the elements of third row are 1, 0, 3. Now, what is adjoint A? Adjoint A is defined as transpose of squared matrix of the same order, each element to be replaced by corresponding cofactor. That is C11, C12, C13, C21, C22, C23, C31, C32, C33. And with what are cofactors? The minor with the proper sign. Proper sign you should always write aside for your ready reference. You know. And now let me work out these C11. How do you work out C11? Delete the row and column. Yes. Now I'll, suggest that when you are finding C11, delete the row and column through A11 and find the value of determinant, but do write these signs in advance, plus, times, so that there is no question of mistake. So you write plus times, delete the row and column through 1 1, that is through 1, and you get 0 into 3 0 and minus 0, so you get 0. So of course I am writing here plus 0, though there is no question of plus 0 and minus 0, we will write 0 finally. Then for the element C12, you write minus sign already in advance. And whatever is the value, that will write in bracket, small bracket. Don't confuse it with matrix. So what is C12 element? Negative 1. Delete the row and column through negative 1 and work out, you get 3 into 3, 9, minus minus plus 2, minus 11. Why I am writing this minus outside and then 11? Suppose this instead 11 it comes negative 11. So it will become negative and negative positive. What happens in the process most of the time, that students they keep this minus in mind, work out the value of determinant, and then they forget to put this minus sign. And once you find out, it is very difficult to check where exactly you have done the mistake. So don't do everything orally. Then for the third element in the first row, it is plus sign. Plus I keep here, and delete the row and column through A13, that is 2, and you get 3 into 0, 0 minus 0, so it is 0. I'll omit this plus minus sign here. And now for element C21, it is minus times. Delete the row and column through A21, and you get minus 1203. So if you work out, you get minus 3 and minus 0, so minus 3. So here it is C, minus is already there because of this minus. So minus of minus 3. Otherwise maybe you have worked out the value of determinant minus 3 and you write down, you forget to put the proper sign. And now you work out rest of them yourself. It will be plus times 1 and minus times 1, and for this C31 will be plus times 2, and C32 will be negative times negative 8, and the last element C33 will be plus times 3. So, and don't forget to write the transpose. Now, so what is the value of adjoint A? It is transpose of, let me write all these working with plus minus signs. Finally, it comes out to be 0, negative 11, 0, negative plus 3, 1 and negative 1. There is no harm in taking one extra step of imposing plus minus signs formally and then working instead of doing a mistake. 2, negative plus 8 and 3. So this is the value of adjoint A, but don't forget to take the transpose that yet we have to take. So take the transpose, write the elements of first row in first column 0, minus 11, 0. Then the second row 3, what is the second row? 3, 1, negative 1, write in the second column 3, 1, negative 1. And 2, 8, 3 elements of the third row, write in the third column. So finally, this is the value of adjoint A. But this is not a question of finding adjoint A. We have to yet work out A into adjoint A as well as adjoint A into A. So let me work out at least A into adjoint A. No doubt there are a lot of calculations and these are lengthy questions, but please keep patience. Write A. What is A? 1, negative 1, 2, 3, 0, negative 2, 1, 0, 3. This is A. We have already worked out adjoint A. Adjoint A we worked out to be, say 0, 3, 2 and negative 11, 1, 8 and 0, negative 1, 3. Now multiply. You know how to multiply? Both these matrices are of the order 3 by 3. So the product will also be a matrix, squared matrix of order 3 by 3. And you know how to multiply, that you take the elements of the first row, multiply respectively with the elements of first column. So let me show you one or two. You get 1 into 0, 0 and minus 1 into minus 11 plus 11. and 2 into 0, 0. Then continue multiplying first row with the second column. You get 3 and C minus 1 and 3 minus 1 minus 2. And then with the third column, continue with the third column. You get 2 into 1, 2, minus 1 into 8, minus 8, 2 into 3, 6. And I leave for you to try the rest similarly, and you will get, see, you will get 11, you find here 11, and 3 minus 3, 0, and 8 minus 8, 0, and similarly you will get the elements of second row as 0, 11, 0, 0, 0, 11. So this is the value of A into adjoint A. And now I leave for you to try, please try yourself that the product adjoint A into A, it is just a matter of taking product, will also be the same 11, 0, 0, 0, 11, 0, and 0, 0, 11. And we have already proved that the value of determinant A into identity matrix is also the same 11, 0, 0, 0, 11, 0, 0, 0, 11. So we can conclude now, that for the given matrix, the A into adjoint A is equal to adjoint A into A, and same is equal to determinant A into I, and hence the result.